Hey everyone, and welcome back to the Deep Dives. Have you ever had one of those days where, I don't know, everything just seems off?
hmm
Maybe your coffee order is consistently wrong, or a package arrives damaged, or, a website just won't behave.
Oh, yeah, definitely been there.
It's incredibly frustrating, right?
Yeah.
But what if I told you there's a powerful data-driven methodology designed to virtually eliminate those kinds of snags, pushing towards near-perfect quality?
Hmm.
Today, we're taking a deep dive into Six Sigma. It's a system that helps organizations achieve, well, operational excellence.
Excellent.
We're going to unpack its core ideas, walk through its famous DMAIC roadmap, and even look at some surprisingly fun ways it's applied. And it's all from this fantastic source material, OpEx Apply Six Sigma to Process Control and Improvement.
And what's truly fascinating here, I think, is that Six Sigma isn't just about, fixing problems when they arise. It's more a comprehensive philosophy. It's about systematically reducing variation and achieving this almost unbelievable standard of quality. We're talking like 3.4 defects per million opportunities.
Wow, 3.4 per million. That's tiny.
It really is. Think about that for a second. It's a standard driven by an intense customer focus and just an unwavering commitment to data.
Okay.
So, our mission today is to explore how its structured problem-solving roadmap, DMAIC, actually guides us through achieving that kind of precision.
And you mentioned something about a simulation.
Yeah, we'll even bring some of the concepts to life with a unique simulation that makes it all feel incredibly tangible.
Fantastic. So whether you're grappling with inconsistent processes at work, maybe trying to understand how major companies maintain such high standards,
Yeah.
or you're just insanely curious about optimizing anything, this deep dive is designed to give you those aha moments and, well, a shortcut to being truly well-informed.
Yeah,
Okay, let's unpack this.
let's do it.
So let's start at the very beginning. What is Six Sigma really at its core? It sounds like a big technical number, but what does it actually represent?
Well, at its heart, Six Sigma is defined by three powerful ideas, as our source highlights. First, it's a measurement.
Okay.
That's that incredible benchmark, 3.4 defects per million opportunities. And this isn't just some arbitrary number. It's a quantified goal for near-perfect quality, rooted in a statistical understanding of variation.
Got it. Measurement. What else?
Second, it's a methodology, specifically that structured five-phase problem-solving roadmap known as DMAIC. Define, measure, analyze, improve, control. We'll definitely get into that.
DMAIC. Okay.
And third, maybe most importantly, it's a philosophy. It's this deeply ingrained commitment to consistently reducing variation, being intensely customer-focused in every single decision, and relying entirely on data to drive improvements, not gut feelings.
That emphasis on reducing variation really stands out. Why is consistency, or, the lack of variation, why is that so absolutely crucial? I mean, my coffee order might be perfect one day, wrong the next. It's just a bit inconsistent, right? What makes that such a big deal for a business?
Oh, it's a monumental deal because inconsistency, that variation you just mentioned, it directly impacts both quality and cost in, well, profound ways. To truly grasp why it's so critical, we really need to understand this concept of the cost of poor quality, or COPQ, as it's often called.
QQ. Okay.
And this isn't just about the obvious, visible costs we all think of, like scrapping a bad batch of product.
Right, the stuff you can see.
Exactly. The real revelation with COPQ isn't just that obvious stuff, it's the silent drain of hidden costs.
The silent drain. That sounds like a crucial insight. Tell us more about those less obvious impacts.
Exactly. Our source breaks down COPQ into two main components. You've got the visible cost things you can easily point to, like rework, extra inspections, warranty claims, rejected products, maybe lost sales from unhappy customers, or late deliveries.
Yeah, seems straightforward.
Relatively straightforward to track, yeah. But then there are the hidden costs. And these are far less obvious, but incredibly impactful, often actually far greater.
Really, more than the visible stuff.
Often, yes. Imagine losing a customer. Not because of one bad product, maybe, but because of a consistently inconsistent experience. That's a hidden cost, lost loyalty. And that can be far more damaging than any single rework job.
Oh, okay. That's
Or
what
think about the slow burn of extended cycle times. Things just taking longer than they should. Time is money, right?
right.
So that inefficiency is silently eroding your bottom line. Other hidden costs, things like excess inventory just sitting idle, the time value of money lost on resources tied up in clunky processes, the energy spent resolving customer problems that shouldn't have even happened. It just shows that poor quality isn't just a nuisance, it's a major, major drain on resources, reputation, and ultimately profitability.
It makes so much sense when you frame it that way. It's not just the broken product, it's that whole ripple effect that costs so much more.
Precisely.
So Six Sigma aims to tackle these by following its famous roadmap, DMAIC. That's define, measure, analyze, improve, control.
That's the word.
And define is the crucial first step, focusing on clearly understanding the problem. Is that right?
Absolutely. The define phase is all about pinpointing where we are now, as our source puts it. It's the stage where an organization may be faced with, many potential projects, commits to selecting and clearly outlining a single project, one that promises clear, quantifiable benefits.
So it's not just about identifying a problem.
No, it's about precisely articulating it, quantifying it.
Okay, this is where the strategy really kicks in then. With, countless problems maybe vying for attention, how does an organization strategically pick the one project that will yield the most impact?
Yeah, that's a critical decision. Our source highlights different ways they might approach it. Some organizations take a continuous improvement focus. They just tackle the obvious problems that keep popping up.
The squeaky wheel gets the grease, sort of.
Kinda, yeah. Others might use a problem-solving focus, maybe brainstorming issues and then hopefully linking them to some bottom-line impact.
Okay.
But the most robust approach, that's aligning with a business strategy, really identifying projects that directly impact core business metrics and have a clear, measurable financial benefit.
That sounds much more targeted.
It is. And once a project is chosen, it's documented in something called a project charter.
Okay, the project charter. What makes that so vital? Is it just like a mission statement, or is it something more detailed?
Oh, it's far more. It's really the definitive document. It lays out the project's objectives, its scope, the anticipated financial impact, all the key stuff.
Oh, like what? What's in there?
Well, key elements include a precise problem statement describing what's wrong in measurable terms, a compelling business case explaining the strategic why, a defined scope what the project will and, importantly, won't address.
Scope creep is real.
Very real. It also includes CTQ requirements, critical to quality. Those are essentially what the customer absolutely demands. A clear goal statement, the team members involved, and a realistic project plan timeline. Take the example from our source about an A320 spoiler panel issue. They were seeing scrap rates consistently around 6-9%.
That sounds expensive.
Millions in annual losses. So the defined fee isn't just about saying high scrap. It's about putting a concrete, measurable value on it and setting a clear, ambitious target, like cutting that scrap rate by half to save millions.
Okay.
And the goal statement then needs to be smart. You've probably heard of this: specific, measurable, attainable, relevant, and time-bound. So there's just no ambiguity about what success actually looks like.
That's incredibly clear a roadmap before you even start driving. That brings us beautifully to measure. As the old saying wisely puts it, if you don't measure it, you can't improve it.
Exactly.
So once we've clearly defined our problem, how do we begin quantifying the challenge in this measure phase?
Right. In the measure phase, the focus shifts. It's now about understanding the current process's capability and, really importantly, the reliability of your measurement system itself.
How reliable your ruler is, basically.
In a sense, yes. It's all about defining what constitutes a defect, identifying opportunities for those defects, establishing the specific metrics you'll track. Then you develop a robust data collection plan and, crucially, start gathering that raw data. You need to truly understand the relationship between your inputs and outputs.
Okay, let's bring this to life with that simulation you mentioned, the X-Pult. This sounds fun.
Yeah, it's a great way to visualize it. So imagine you're in 15th century Rome. You're part of a team of 5 gladiators.
Gladiators, okay.
And you're handling a catapult. But it's wildly inaccurate. It consistently misses a 2.5-meter target.
Uh-oh.
And yeah, with tragic consequences, the source says killing some of your own men by accident.
Oh, dear. High stakes.
Very high stakes. Your general has commanded you consistently hit the enemy at 2.5 meters every time. So for Simulation 1, your gladiator team would simply launch that catapult, say, 20 times.
Okay.
And every single miss, every centimeter off target, gets meticulously recorded. It's about capturing that raw, unvarnished truth of your current performance. Where are you really hitting?
Got it. Just collect the baseline data.
Precisely. And for that data to be meaningful, it's absolutely crucial to have an operational definition.
Operational definition. What's that?
It's just a precise, unambiguous description of how to get the value of whatever you're measuring. How exactly do you measure the distance? From where to where? This ensures everyone measures the same thing, the same way, every single time. That gives you reliable, consistent data to work with.
Makes sense. Consistency in measurement is key. So we've gathered all this raw data from our unfortunate catapult launches. How do we display it and make sense of it, rather than just staring at a spreadsheet full of numbers?
Yeah, raw numbers aren't always intuitive. This is where visual tools become invaluable for spotting patterns. We use things like histograms, which show the distribution of your data, like how often are you close, how often far away,
Right.
trend charts to see performance change over time, and X bar R charts. These are especially critical.
X bar R.
Yep. Think of them as visual guides. They tell you if your process is predictable and stable, or if it's just wildly erratic and needs intervention. They show the average, X-bar, and the range of your measurements over time.
Ah, okay. So it shows consistency.
Exactly. Both
Yeah.
the average performance and the consistency around that average. So for simulation 2, our gladiators would take, say, 100 measurements, aiming for that 2.5 meters plus minus 0.2 meters target zone.
100 launches. Okay.
The goal is to generate an X-bar R chart to visually track how stable their catapult actually is, and then calculate something called the Process Capability Index.
Process Capability Index. What does that tell us?
It essentially tells you how well your catapult can meet that 2.5 meter target consistently, given its current variation. Think of it like a golf handicap for your process.
Right.
How consistently can you hit that perfect shot? Or how much room for improvement do you still have? It compares the voice of the process, what it's actually doing, with the voice of the customer, what you need it to do.
Got it. So measures about getting the facts straight visually and numerically. Okay, we've clearly defined the problem with our wayward catapult. We've measured its current accuracy and stability. Now we move to analyze.
Right.
We have our data. We see the scatter. Now what? It's time to find the why, right? Why is our catapult so inconsistent?
Exactly. The analyze phase is dedicated to assessing those patterns and trends you've uncovered, connecting the inputs to the outputs. We're looking to identify the sources of variation and, crucially, pinpoint the vital few X's, those critical inputs that truly drive the problem.
The vital few X's.
Yeah, it's about understanding that Y-FX relationship, where Y is the undesirable outcome, like missing the target, and the X's are its root causes.
Okay, so how do you find those X's?
Well, one of the most common and effective tools here is the cause and effect diagram. You might know it as a fishbone diagram or Ishikawa diagram.
Right, the fishbowl. I've seen those.
Right. It's a great visual tool. It helps teams systematically brainstorm and categorize all potential causes related to an effect or the problem. Often they categorize them into areas like man or people, machine, material, method, measurement, and environment. The 6 M's.
Helps organize the brainstorming.
Totally. Keeps it structured.
What if the problem is deeper, though? What if those initial causes you brainstorm aren't the real root cause? How do you dig into the layers of causation?
Good question. That's where the 5 whys analysis comes in. It's deceptively simple, but incredibly powerful.
Just keep asking why.
Pretty much. The idea is to determine the potential root cause by repeatedly asking why, what caused this problem. You aim for at least 5 times, sometimes more. You keep digging deeper into the symptoms until you arrive at a foundational cause. Something that, if you address it, would likely prevent the problem from happening again.
So it forces you beyond the superficial fixes.
Exactly. It gets you past symptom treating.
So if our gladiators are seeing their catapult consistently miss, a fishbone diagram might show them categories like bad materials or untrained operators.
Right. Potential causes.
But the 5 whys pushes them deeper.
Yeah.
Okay, why are the materials bad? Maybe inconsistent supplier quality.
Yeah.
Then, okay, why is that inconsistent? It forces them to peel back those layers.
To find the true underlying issue for why they couldn't hit the 2.5 meters target accurately. It makes it really clear why they need to go beyond just, say, training the current operators if the real issue is faulty equipment design.
That makes a lot of sense. Find the root cause. Okay, so once we've uncovered those root causes in the analyze phase, it's finally time for improve. This is where we actually develop and implement solutions, right?
Yes, exactly. This is the action-oriented phase. The improve phase focuses on verifying those critical inputs, those vital few X's we found in Analyze, and determining their optimum settings.
Figuring out the best way to adjust things.
Right. It involves brainstorming and developing a range of potential solutions, then carefully selecting, optimizing, and maybe even piloting the best ones to achieve the project's goal, which, for our catapult example, is consistently hitting that 2.5-meter target.
How do teams usually come up with these solutions?
Well, common ways include brainstorming sessions, obviously, but also studying best practice comparisons, benchmarking against other successful processes. Maybe another catapult team is doing really well.
Catapult benchmarking. Love it.
Or conducting thorough research, talking to staff, reading books or online resources, consulting suppliers, even talking to customers, or in this case, maybe the commanding general.
Okay, so lots of idea generation. But when selecting a solution, what key factors need to be carefully weighed beyond just what sounds good on paper? I imagine there are always trade-offs.
Absolutely. It's definitely not just about what could work, but what will work effectively and sustainably in the real world. Our source details some crucial considerations here.
Like what?
First, there's the impact. You need to consider the time frame of the improvements. Is this a long-term fix or just a short-term Band-Aid? And what type of improvement is it? Are you truly removing the root cause, or are you just adding, say, an inspection step or more training?
Okay. Root cause versus symptom fix.
Precisely. Then there's cost. This covers both the initial implementation costs, maybe training staff on a new procedure, buying new materials, capital investments, and also the ongoing costs to sustain that improvement.
Right. It's not just a one-time thing.
Rarely. And finally, time is a huge factor. There are technical time constraints. How long does it actually take to implement? Potential political time constraints, maybe competing priorities in the organization. And cultural time constraints. How long might it take to get buy-in and real support from all the stakeholders involved? It's really a balance of all these elements.
That makes the selection process much more robust than just picking the first idea that comes up. Okay, so bringing it back to our Pult gladiators for simulation 3.
Yep, the final simulation.
After thoroughly analyzing their root causes, maybe they found it was the release mechanism and brainstorming solutions. They'd come up with an improvement plan for their catapult.
Right. Maybe they design a new trigger or a better way to tension the ropes.
Then they'd test it out, collect data for another 100 measurements, generate a revised X-bar R chart with new control limits, and calculate the new process capability index.
Exactly. This is where they actually see if their improvements made a real measurable difference. Did the average get closer to 2.5? Did the variation shrink? Is the process now capable?
The moment of truth. Okay, that brings us to the final and absolutely crucial step in DMAIC, control, ensuring that all those hard-won improvements actually last. What does this phase aim to do, and why is it so vital? Seems like the work is done after improve.
But that's a common misconception. The control phase is arguably one of the most important because it's about implementing robust mechanisms to sustain the gains.
Sustain the gains, okay.
It involves validating your monitoring and control systems, developing clear standards and procedures, and critically implementing things like statistical process control, SPC, to keep the process stable over the long haul.
SPC.
Statistical process control. Using those control charts, like the X-bar R chart we talked about, on an ongoing basis to monitor the process and react if it starts to drift out of control.
Okay. Continuous monitoring.
Exactly. Because as our source plainly states, if you are not improving, you're going backwards. So this phase is all about making sure those valuable improvements become the new permanent way of operating, not just a temporary fix.
How do organizations actually lock in these changes? How do they prevent falling back into old habits? It seems really easy for things to just revert over time.
It is. Which is why this phase is so vital and, honestly, quite multifaceted. It really comes down to a few key areas. First, you need solid documentation and monitoring.
Okay.
This means having a process control plan. Think of it as your living blueprint. It tracks the status of all significant process characteristics, how they're monitored, and what to do if they go out of spec. It ensures improvements are sustained.
A rule book for the new process.
Kind of, yeah. Then there's people and communication. This isn't just about sending out memos. It's about fostering real two-way communication, motivating people for the change, providing encouragement, and making sure everyone understands the why behind the new processes.
Getting buy-in.
Absolutely. And this often involves effective training and workforce skills development. You have to equip personnel with the new knowledge and skills they need. Finally, there's verification and response. This involves clearly defining your measures and indicators, like key performance indicators or KPIs, and setting the frequency for reviews and audits
Checking up on it.
regularly. The audit process then systematically checks if the improvements are holding, documents the findings, and identifies any non-conformances, places where things aren't following the new standard.
And if you find problems.
Any issues trigger corrective actions, often using a formal SIR process corrective action request. You investigate the reasons, document the actions taken to fix it, and then verify through follow-up audits that the fix was effective.
Closing the loop.
Exactly. The ultimate goal here, as our source puts it, is achieving standard work practice, where the new, improved best practices are formalized, documented, and become the common, everyday way of doing things. You ideally let these new standards stabilize for, say, 3 to 6 months before introducing further changes.
Let it become routine. So what does this all mean for making changes actually stick? For truly achieving, like, self-sustaining processes?
It means you're truly institutionalizing the process. The goal is to fully verify the financial benefits, the cost savings, the profit growth that you projected back in the define phase, and then crucially, ensure continuous monitoring and proactive adjustment. This constant vigilance is just essential for achieving and maintaining that long-term operational excellence. It prevents that drift back to the old ways and helps build a real culture of sustained improvement.
Phew, what a journey through the world of Six Sigma. That was comprehensive. We started by understanding its core as a precise measurement, a powerful methodology, and really a guiding philosophy. Then we journeyed through that entire DMAIC roadmap from defining the problem and its often hidden costs,
Right, the COPQ.
through measuring performance with vivid examples like the Pult gladiators,
Always fun.
analyzing root causes with techniques like the 5 whys, improving processes by carefully weighing solutions, and finally establishing those controls to sustain those hard-won games. It's truly about bringing that idea of near-perfect quality into reality.
And if we connect this to the bigger picture, Six Sigma's relentless emphasis on reducing variation, driving defects down to that tiny 3.4 per million opportunities, it fundamentally shifts how organizations view quality.
How so?
Well, it highlights that knowledge is most valuable when it's actually understood and applied. And that continuous improvement isn't just, an aspiration or a project, it's really a necessary state. To prevent what one of our sources called simply going backwards, it encourages critical thinking at every single step, questioning assumptions and always building solutions on solid data.
So what does this all mean for you listening out there? Beyond, the corporate boardroom or a factory floor, here's where the idea truly resonates, I think. Think about your own daily life or work. Where do you maybe accept good enough when actually a Six Sigma kind of mindset could dramatically improve things?
That's a great question.
It raises this important point. If the cost of poor quality includes both the obvious reworks and those hidden costs, like lost time, frustration, maybe even lost loyalty in personal relationships or side projects, what are the subtle inefficiencies in your world that are silently chipping away at your time, your energy, or your satisfaction?
Yeah, where's your personal COPQ?
Exactly. It's a really powerful idea to mull over. Thanks for joining us for the deep dive.